All right, guys, welcome back. So where we were at here is we were going to start talking about how to apply this bearing stuff. But before we do that, I need to review with you something that you learned in geometry class. And what that is alternate interior angles. And you have parallel lines, and you can recall that these little arrows on lines mean they're parallel to one another. And you draw another line that we call a transversal. It forms alternate interior angles. And those alternate interior angles must be congruent if the lines are parallel. Now in geometry class, your teacher probably told you, I know I tell my kids, to always look for z's. Here's what I mean by a z. And I know it's hard for me to draw on this little tablet. But whenever you see a z and the top and the bottom of the z are parallel to one another, then those alternate interior angles would be congruent. Alright, so in these problems, you're going to be looking for those z's, or it could, show up like an n. And in that case, those would be my congruent angles. But that's what you're looking for. So obviously in example 12 there, it should be pretty straightforward. But you'll notice that, oh look, check it out. This makes a little z. And the lines are parallel. Well, that means that these alternate interior angles would be congruent, which means x would be 40 as well. Alright, here in this example, and this is what you're going to see when we do these application problems, because at any point where you're starting or stopping, I'll draw a little compass rose and I'll tell you about bearings. So in this situation, it's like, hey, somebody starts here and they travel on a bearing of 40 degrees to a new spot. Okay, so here's my little bearing of 40 degrees. 0 is at north, rotate 40 degrees clockwise. That's the bearing I'm traveling on, and then here's where I end it. Okay, and you'll see an example in just a second where I use these things. So in order to solve for things, the first thing we got to be able to do is to determine these missing angle measures. Now, of course, if this is a compass rose and this is north and east, then these two angles have to add to 90 degrees because we got perpendicular axes there, which makes x 50. All right, and then by using alternate interior angles, there's two pairs of alternate interior angles I can look at here. There's this one here, formed by this z, which makes, if this is 40, then y will be 40. And then, of course, these two still add to 90 because you have the north-south line and the east-west line are perpendicular. So this would be 50 degrees. But another way you could think about it is look at this z. Oh man, I know it's hard for me to write on this tablet. But then this angle and that angle will be congruent as well. So, and again, we'll do an example in just a second where you see how that applies. So, moral of the story, look for z's. And then you have alternate interior angles, and you know they're congruent. So you can see right here in this problem, I'm going to have a z here, have a z here, there's a z here. There's so many of them in this diagram, and I'll point them out as we go and solve for this. All right, so Mr. Donaldson went backpacking over the weekend. Okay, this is wishful thinking. Rather, I was trapped inside my house on quarantine, sadly, but I did camp out in the living room just to have a camping experience. It was awesome. All right. On the first day, he hiked from the trailhead for 8 miles. So here's where I start. Notice I put a compass rose wherever I'm located. All right. So I started here, and I hiked for 8 miles on a bearing of 50 degrees. So I'm standing here at the trailhead. My compass is pointing north. I rotate 50 degrees clockwise, and then I start hiking along that bearing for 8 miles. All right. So then I stop and I set up camp 1. So here's camp 1. So before we move on, this is where I ended, let's just take a look at what we would know. So we knew this length was 8 miles. We knew this was 50 degrees. And again, if the north-south line and the east-west line are perpendicular, then this would be 40 degrees. So I know x is 40. These two must add to 90. And now I'm going to look at my little z's here that I've been pointing out. So here's one. All right, maybe we'll go with the green here. So notice this little upside down rotated z. If this is 50, then this y must be 50 as well. All right, so there is that little z. Here's another one. Let's follow the pen. You could see there's another little z. So if this is 40, then this is 40 as well. Cool. So that's all we know based on that day 1 of travel. All right. So the next day, I left Camp 1, so I'm leaving Camp 1, so I put a little compass rose here at Camp 1, and I go on a bearing of 160 degrees. All right, so let's take a look at what that looks like. So here's 0 degrees, and I'm going to go on a bearing of 160, so I'm going to go 0 to 90, but I want to go 160, which is this. So this is the path I'm going to take out on this next day. So what that means is, if that is a bearing of 160 degrees, but this is 90, well, that is simply 70 degrees past 90. The other thing, too, is that 160 degrees is 20 degrees before 180. Remember, due south is 180 degrees. So if I'm on a bearing of 160, that's 20 degrees prior to going south. So I could have figured out that this was 20 because it's 20 degrees less than 180. And also these two need to add to 90 degrees because they're complementary. And now I'm going to look at my z's again, and I can figure out information about this stuff down here. So look, here's this z with a 20 degree angle. Come down, bam, up. This would have to be 20 degrees. All right. And now let's take a look at the next day. So here I am at Camp 2, and how do I get out of this thing? On the final day, I leave Camp 2, and I go on a bearing of 280 degrees. All right, so here's my compass rose. I'm standing there, my compass pointing north, and I want it to point at 280, so I start rotating. There's 90, there's 180, there's 270, boom, 280. Gets me home. So you'll notice that 280 is 10 degrees past 270, and that's a 20, sorry. All right, so now I can figure out all these other angle measures. So let's go back and fill in the ones I already figured out. I knew y was 50. I knew z was 40. I knew a was 70. I knew b was 20. I used my alternate interior angles to figure out that, I think that's, what is that, a c is 20. All right, I knew that 280 degree bearing is 10 degrees past 270, so I knew that D was 10. And then to find E, I just know that these three angles make a right angle. They add up to 90 degrees. So 10 and 20 is 30, which leaves 60 for this guy, for E. And then the last one, F, and the way I'm going to find F is by looking at these alternate interior angles right here. Follow my pen. Here's my little Z. So this little angle is 10, this little angle is 10 as well. So when you're reading these problems, that'll be your first step, is to just go through and say, all right, start here, what's my bearing? You're using complementary angles, you're using alternate interior angles to find all those missing angle measures. You do some practice like this in homework tonight. All right, so the next step is to take all this information and I'm going to put it into just the triangle. So all I'm going to do now is focus solely on the triangle. So I'm only going to look at that triangle. All right, I'm going to plug in all the angle measures I know. So I know that 40 and 10 is 50. I know that 50 and 20 gives me 70. And I already knew that was 60. And one quick thing I could do to determine if I'm on the right path is, well, all the angles in a triangle have to add to 180 degrees. And in this case, they most certainly do. So 50, 70, 60. And I know this side is 8. So I know that this was 50, 70, 60 degrees. And I know the only distance I know is that this was 8 miles. All right, so the last thing is actually applying what we learned last week. So use this triangle in the law of sines to find the distance from Camp 1 to Camp 2. We'll call that x. And the distance from Camp 2 back to the trailhead, we'll call that y. All right, so remember, law of sines, pretty straightforward. I know that this is 60 degrees, and the side across from it is 8. I know that this is 70 degrees, and the side across from it, I don't know, is y. I know that this is 50 degrees, and the side across from it, I don't know, is x. So remember, the way the law of sines works is the sine of some angle over the opposite side is equal to the sine of some other angle over its opposite side. So I'm going to say that the sine of 60 over 8, 60 degrees, sorry, the sine of 60 degrees over 8 has to equal the sine of 50 degrees over x. And I'm going to solve that. And also I'll do the same thing for y. So the sine of 60 degrees over 8, that was given to me, has to equal the sine of 70 degrees over y. So I'm just going to cross multiply both of these, use my calculator and solve. So here we go. This is x times the sine of 60 is equal to 8 times the sine of 50. Divide both sides by the sine of 60. And I get that x is equal to 8 times the sine of 50 divided by the sine of 60. And over here when I cross multiply, and I'll punch that in my calculator in a second. Over here when I cross multiply, I get y times the sine of 60. So y times the sine of 60 equals 8 times the sine of 70. Then I will divide both sides by the sine of 60 here. And I get y is equal to 8 times the sine of 70 degrees divided by the sine of 60 degrees. So here's my calculator. Make sure I'm in the right mode. Remember, the way you test if you're in the right mode, you say sine of 30 should be 0.5. I'm good to go. The other thing you do is just hit the mode button, confirm you're in degree mode. So here we go. 8 times the sine of 50. Close that parenthesis, divided by the sine of 60. And you guys should be punching buttons in your calculator and confirming you're getting the same thing. I get x is about 7.08 miles. Alright, so 7.08 miles from Camp 1 to Camp 2. Alright, and then I'm going to do this one. So I'll use my calculator. And I have 8 times the sine of 70. Close that parenthesis, divided by the sine of 60. And I get that y, the distance from Camp 2 back to the trailhead, is about 8.68 miles. So, what we learned today is the bearing concept, okay? And that's the big thing, because when we're in terms of application, that's how it works. You'll be given distances you travel, you'll be given bearings or angles that you've been traveling on, and then you could draw triangles and solve for missing pieces. And that's kind of the big important part of this unit, is the application, how you can apply it. And if we were in school, we'd be going outside and I'd be having you guys using your iPhones and tape measures and practicing applying this. But sadly, you're stuck at home. But you could get your iPhone out and determine what's the bearing to your refrigerator, or something along those lines, or go outside and play with your phone if you're super nerdy like me. I'll probably do that later. Anyway, so thank you guys. I know this is a bit complicated. Please don't hesitate to ask me for help if you need me, and I hope things are going well. Namaste.